So in the today's session, the agenda is that we're going to solve few mathematical problems. So far, those people who have just got started, we have a playlist which is running on the YT. So the previous videos around time complexity recursion has been already there. We'll try to move ahead a next step from there. So in the today's session, we're going to talk about few of the basic fundamental problems of the math, understand how mathematically it would be solved, and then we'll write the code to understand it. So let's get started with the very first problem. So let me share my screen. I hope you are able to see the screen. This is the mathematics part 1. Let's first of all talk about the first problem which is there on the hand. Okay. So the first problem says that, let me go and put it here. Problem statement says that find the count of digits in the number. This is the problem. Find the count of digits in the number. What that means? What that means is that, let's say that if I have a number like 4, 5, 6, how many digits are there in this number? 1, 2, and 3. So the number of digits is equals to 3. Let's take another example. For example, 1987. How many digits are there in this number? 1, 2, 3, 4. Right. So as a human, it's very easy for us to go and calculate the digits, and we can quickly say that, hey, there are 4 digits. But I want to find this solution of this problem programmatically. I have to find a logic. I have to go and find a logic that how many digits are there in this number. Can you guys put your suggestions into the comment section that how do I go and find, what should be the logic to go and find all the count of the digits in the given number? Say for example, let's take another example. Let's say that for the example is 194526. How many digits are there in this number? 1, 2, 3, 4, 5, 6. So as a human, it's very simple. I can quickly go and say that it is having 6 digits. But if I have to go and write a program, sir, if I have to go and write the program or the code to solve this problem, how go and do it? So what we can do is that we have to start somewhere. Right? We have to start somewhere. So if let's say that the number is 3, 2, 4, right? We have to start somewhere to find the count of the digit. Now what happens if I go and divide this 3, 2, 4 by 10, right? What is the value that I get? 32.4. If I only take this portion, right, the number gets reduced by 32 and it's one count. If I again go and repeat this, 32 divided by 10, the value should be equals to 3.2. I only take this part, the value is 3. And again, this will take one step. Now I'm left with 3 divided by 10. The value will be 0.3. The value is 0. This itself will take one step. Now the number is already 0. I only should continue till the time I reach 0. So how many steps? 1, 2, 3. So the number of digits will be equals to how much? 3. Let's take another example. Let's say that I have number called as 1, 2, 3, 4 and I have to go and find. Let me take the number as little more complex, 5, 6, 8, 9. And I have to go and find that how many digits are there. Very simple. What I do? First of all, I go and divide this number 5, 6, 8, 9 divided by 10. The value should become equals to 568.9. I only take the integral part. So the value becomes equals to 568. This takes one step. Again, I do 5, 6, 8 divided by 10. This becomes equals to 56.8. I take only the integral part. So which is 56. This again take one step. I again take 56 divided by 10. This equals to 5.6. I only get the integral part. This is still take how much? One step. Again, I go and do 5 divided by 10 equals to 0.5. This value is 0. This again takes 1. Sounds it is 0. I will not move forward. From here to here, how many steps? 1, 2, 3, 4. The total number of digits are 4 digits. Fair enough. Am I clear? Is the logic clear to everyone? What we need to do? I need to keep on dividing the number by 10 and then I should be able to get the answer of it. Now this whole logic, what I'll have to do? I'll have to go and write in the form of a code. So let's quickly go to my code. I'll open my VS Code. And what is the setup that I have used for the, so I'll just talk about the setup. So the setup that I have used is, since I'm writing the node.js, I'm writing the JavaScript code. So I have installed VS Code, right? And on my local machine, I have node.js installed. Why node.js installed? So that I can go and execute JavaScript code. This is the basic setup which I have. I believe most of you will already have it. So I'm trying to go and find the count of digits. Fair enough. Let's quickly go and write the code. Let me go and define a file. Let me call this file as maths problems.js. Let me go and define this. So what I'm trying to do, I'm trying to count the number of digits. Fair? I'm trying to count the number of digits. Let me go and define a function called as function, and I go and say that count digits. And I have to take that number as an input. So I take that number as num. Then what I need to do, if number is equals to 0, if number is equals to 0, what should I go and do? I should simply go and return. One. Otherwise, I go and initialize a counter, count equals to 0. And then I go and say that while n is not equals to 0, I go and say that num equals to math.float. Why float? So that I can go and take the integral part and I go and divide num divided by 10. And I increment the counter of count. And once it is done, I should go and return count. This is the code that we have written. Count number equals 0, return 1. Otherwise, I go and divide it. Let's try to go and run this code. So if I go and test this code, console.log, and I go and say that number of digits in 5, 4, 6 is, and let me go and pass this method called as count digits, and I go and pass 5, 4, 6. Let's try to run this and see what happens. So I go and say that node, and I go and call it as problems.js and hit enter. And the answer that I got is number of digits is 546 is 3. Let's test it one more time. Let me make it 546, 1, 2, 3, 4, 546, 1, 2, 3, 4. And if I go and run this again, the number of digits here is 7, which is absolutely correct. So this is our code base. Let me quickly put that into our whiteboard, and let's do a quick dry run so that we all are confident that what we have done. So let me put this code here. Right, this is the code here. Let's do a quick dry run. So let's say that I go and call this function like this, count digits, and the number is 4, 5, 6. As soon as I go and do this, this number turns out to be initially 4, 5, 6, not equal to 0. So I come here. Initially, the value count is 0. Number is what? 4, 5, 6. I do this math.float number divided by 10. So it means that math.float 456 divided, it will be 45.6, which value will be equals to 45. So when I go and do this, the number becomes 45, and the count increments value increases to 1. Next time when the loop runs, this number has now become equals to 45. And again, when I go and do this, this number will turn out to be 4. The count value increases to 2. Third time again when I go and run this, this value has become equals to 4 divided by 10. This value has become equals to 0. This number has become equals to 0. So finally this count value has become equals to 3, and I go and return it. This is a iterative solution of finding the count of the digit, the number of digits in a given number. Is that making sense to you people? Is everyone clear on this? Okay, now a challenging problem for you people. Can you convert this code? As I said that we have already covered recursion. Can we convert this code? Can we convert this code into recursive code? We have written a iterative solution. Can you guys convert that into the recursive code? Just give it a try. Meanwhile, you're writing the code. Let me get started. So I have to convert. So how the recursive code will work out? Let's say that I have a number called as 3489. Okay. Once I have divided, once I go and divide this number by 10, it becomes 3489 divided by 10. It becomes 348.9, and I'm only left with 348. So initial my problem statement was to go and find the number of digits in 3489. Once I have divided by 10, now I have to go and find the number of digits in this number. Plus 1 will be my answer, right? So at any time, let's say that this function is fn, right? Fn will be, once I go and divide n by 100, it should be equals to f of n minus 1 plus 1. Where? Let me again explain you. Let's say the number is 5, 6, 7, 8, 9. Right now, I don't know how many times or how many digits are there in this number. Let's assume that. So what I go and do, I just go and try to go and divide it by 10. Divide by 10. And on dividing by 10, if I get a number which is not equals to 0, I say that, okay, at least it will have one digit. And then I have to go and find the remaining element. I have to find the digit in a smaller number. And this I have to go and repeat it again and again. This I have to go and repeat it again and again and again. So this is more of like a recursive problem, right? For example, if I go and build a recursive tree, let's say the number is 5, 6, 7, 8, 9. What I go and do? I go and divide by 10. When I go and divide by 10, it becomes 5, 6, 7, 8. Then again I go and divide by 10. It becomes 5, 6, 7. Then I again go and divide by 10. It becomes 56. Then I again go and divide by 10. It becomes 5. Then I again go and divide by 10. It becomes equals to 0. So if you see here, every step I am doing the same thing. Every step I am doing the same thing. Since I'm repeating the same thing again and again, this problem could be solved using the recursion also. This problem could be solved using the recursion also. So let's try to see the logic for it, how we can solve it using the recursion. Let me go directly to my code, VS Code. And let me go and write a logic called as function count. And now I go and say the count recursive, and I take the number pair. Now, if I go and count this parse int, and I go and say that n divided by 10 is equals to 0. Now, what this math.floor was doing, the parse int will do the similar thing. I'm just giving you another way of finding the integral part of it. If parse int n divided, n is number here, num divided by 10 is equals to 0, in that case, I should go and return 1. Return 1. And if that is not the case, this is my base condition, boss. This is my base condition, sir. Guys and girls, ladies and gentlemen, this is my base condition. And then I go and return the logic. I go and say the return. If that is not the case, it will be at least 1 plus count r. And then I go and pass parse int, and I go and pass n divided by 10. Let's try to see if this works. I go and define this by R. And I also go and remove this by R. Let's try to run this now. Okay, there's some issue. What it is, let's try to see that n is not defined, n is not defined, this should be num. Okay, let's try to run this. And the answer is absolutely correct. So this is a recursive solution. This is a recursive solution of the same problem that we have been trying to solve. Let's quickly put that on the screen right now. Let's try to see that how did it work. So in the very beginning, what I did, I go and call this count. Guys, please pay attention. I go and say count 3, 4, 5. So the first time when the recursive call happened, the number value is equals to 345. Now this parts into number by 10. This will be equals to 34, which is not equals to 0. So it comes here. And then here what happens? 1 plus I go and make a recursive call. Those people who are missing recursion, please go and watch recursion wala video. I have already explained everything in detail there. So the second time when the recursive call is done, what is happening? The number which is passed, is 3, 4. So the number here in the second time will be 34. Again, when I come here second time, number here is 34. 34 divided by 10 will be equals to 3. 3 is not equals to 0. I come here, and then here inside this, what will happen is I'll go and add 1 plus, and then third time the recursive call is happening when the number passed is equals to 3. The third time when it happened, the number passed is equals to 3. 3 divided by 10. 3 divided by 10 is equals to 0.3. Percent will be equals to 0. So this holds true. I go and return. I hit the base condition. And then what happened? I go and return 1. So I came here. It became equals to 2. From here it becomes equals to 2 plus 1. And finally it returns 3. So this will get me the value as 3 as the answer. So this is how we can go and find the count of digits in a number in the both iterative as well as the recursive way. Now the question for you people, what will be the time complexity of this iterative code? What will be the time complexity of this, sir? Time complexity. What will be the time complexity of this problem? If the number is 0, 0, 0, it will be counted as a single 0 itself, right? 0, 0, 0, 0, 0, 4 times 0, all are effectively considered as a single 0 itself. The time complexity will be order of n. But what is n? N is my number of digits. Fair enough. In the iterative solution also, my time complexity will be equals to order of n. What will be the space complexity here, sir? Anyone in the class? What will be the space complexity of this? The space complexity here will be, now it doesn't look anything, but it will be still order of n. Why? Because recursion internally makes use of stack data structure. For recursion to work, it internally makes use of stack data structure. So it will have order of n, not order of 1. It will be order of n because internally for the recursion to work, it makes use of a data structure called stack, which has a space complexity of order of n bots. Fair? Cool. Now let's try to move to the next step. We have done the first problem. Let's move to the next problem. And the next problem says that given a problem, given a number, and it's not a string, by the way, it's a number, it's a digit. Given a number, explain if it's a palindrome. Given a number, explain if it's a palindrome. What is a palindrome number? Palindromic number is a number which, if you read from the left or you read from the right, it is one and the same. For example, if I have a number called as 1 to 1, if I read from the left or I read from the right, it's always same. So I'll go and say that it is a palindromic number. If it is a single digit number, for example, 3 is always palindromic, because whether I read from the right or read from the right, it's the same digit, which is 3. It's also palindromic. But if I take a number like this, 1, 2, 3, 4, if I'm reading from the left, it is 1. When I'm reading from the right, it is 4. 1 and 4, they are not equal, so it is not a palindrome. Fair enough? So again, as a human, to know if a number is palindrome or it is not a palindrome is very easy. It's very straight. Okay. Now we have to go and identify if a number is palindromic or not. As a human, I know that if a number is 1, 2, 3, 4, I know that I have to see from the left, I have to see from the right, and I go and compare this. If 1 is equals to 4, no, then it is not a palindrome. Fair? But how do I do it mathematically? How do I do it programmatically? How I can write the code to go and find it out? So we can divide this problem into the 2 steps. What I can do first is that, first of all, we should have a number called as 1, 2, 3, 4. The next step that we should do is that we should go and try to find the reverse of this number. Reverse of this number will be 4, 3, 2, 1. So this is original, this is reverse. And now what I need to do, I need to go and compare original and the reverse. If this are same, then I go and say that yes, it is palindromic. If no, then I go and say no, it's not palindromic. So my question now reduces down to what I'll have to do. I'll have to first go and find the reverse of a number. Any number that has been given to me, let's say the number given is 1, 2, 3. I have to go and find the reverse of this. I have to go and find the reverse of this number. Can you guys help me understand? How will I go and reverse this number? How can I go and reverse this number? Any trick? Any thoughts? Any logic? Can you guys just put that? Help me understand. How do I go and reverse this number? What logic should I go and make use of it? What should I do so that 3 becomes in the beginning, 1 comes at the last? I cannot use the inbuilt method, right? I cannot use the reverse method. This is not allowed. This is the DSA session. Everything that we have to do, we have to write logic ourselves. That's where you have to put the brain. You should not use any kind of inbuilt methods. What we can do here is, sir, let's say that my number here is 1, 2, 3. What we do is that we go and try to find, first of all, we go and say that, the reverse, we initialize the reverse number as 0 in the beginning. Okay. Very first step, what we do, we go and divide 123 ampersand 10, right? And whatever that value comes out, the value will be equals to how much? 3, right? So this is 1. And then what we do is 123 divided by 10, and this value becomes equals to 12. So what we do, we go and apply this formula. Reverse equals to reverse into 10 plus this number, which is 3. So this equals to reverse initial value is 0. 0 into 10 plus 3 is equals to 3. This happens first. Next time, now my number which is left is 12. So I go and divide 12 ampersand 10, which is equals to 2. And then I did 12 divided by 10, which is equals to 1. Again, I go and apply this reverse equals to reverse into 10 plus this number 2. What is the reverse? It was 3 into 10 plus 2 equals to 32. Again, we do it the next time, third time. I have the number left, which is 1. 1 ampersand 10 is equals to 1. And then 1 divided by 10 is equals to 0. And then I again go and do the reverse equals to reverse into 10 plus this number, which is 1. It was 32 into 10 plus 1, which is equals to 3 to 1. Now, since it is left, I cannot further do. So this is my final reverse number. This is my final. So original number is 1, 2, 3. This was original. And the reverse number is equals to 3 to 1. If I go and do the comparison, this is false. So this is not a palindrome. See, the writing code is the easiest part. The very first thing that you need to know is that you have to be crystal clear with the logic. Is everyone clear with the logic, guys? Ladies and gentlemen, let's make sure that whatever time that you're spending, I know it is free, but it's not actually, right? It is the time which you are investing here. So make sure that next half an hour, 1 hour, whatever time that we are sitting, we make the best out of it. Each of you at least try to bring 10 more people. I think that will only motivate me to keep on bringing these lives. Teach you data science, teach you machine learning, teach you full stack development, teach you Java stack, teach you IoT. I'll teach everything for free. But the only thing that I expect is a little support. Are you guys clear on this? Does it make sense? Fair? So now using this logic, let's try to go and write the code. So what I do is I'll go to my VS Code. And what we do now is that, let me go and comment all this code that we have written. And write the another code called as, and let me go and call it as checking if it's a palindrome. So what I go and do is that I go and define a method, right? I go and call it as function is palindrome. I take this number. And what I do is that, let me go and call it as let temp equals to some number. And let reverse equals to 0. And then I go and say while temp is not equals to 0. Then what do? We go and say that n is equal to temp ampersand 10. And then we go and say that temp equals to parse int temp divided by 10. And then I go and say the reverse equals to reverse into 10 plus n. And once it is done, I have to go and return temp if number is equals to reverse. Let's try to see if this works. So let me go and call it as console.log. And I go and say that is palindrome. And I go and check for 1. And let me copy paste for the multiple options. And it will be 1, 2, 3. And I go right here as 1, 2, 3. And then it is 1, 2, 1. And it should be like 1, 2, 1. Fair enough. Now what should I go and do is that I should go to the terminal, new terminal, and I should go and write it as node. Sorry, I already have this. Node, and I go and call it as problems.js. If I see here, 1, it is saying that it is true. 1, 2, 3, it is saying as false. 1, 2, 1 is showing as palindrome. So our code is working perfectly fine. Let's quickly take it up and tries to do a quick dry run. So doing dry run is a practice that people should definitely have, which will help you to avoid the bugs and also understand the logic well. So if I go and put it here, and let's try to do a dry run here. So if I go and call this function as one is palindrome 1, 2, 3. So what will happen? Temp value becomes equals to 1, 2, 3. Num value is equals to 1, 2, 3. I come here, reverse initial value is 0. Now initially the value of temp is 1, 2, 3. Now when I go into this n, the value of n becomes equals to 3. Temp becomes equals to 12. And reverse equals to, this reverse is equals to 0 into 10 plus 3. So reverse becomes equals to 3. Next time when it again goes, the temp value is equals to 12. N becomes equals to 2. Temp becomes equals to 1. And the reverse value becomes equals to how much? 3 into 10 plus 2. So this becomes equals to 32. The next time it works, the value of the temp remains 1. N value becomes equals to 1. Temp becomes equals to 0. And reverse becomes equals to 320 plus 1. It becomes 321. Next time the temp value is equals to 0. So it's not satisfied. So the reverse is 3 to 1. So this reverse is 3 to 1. Number is 1, 2, 3, which is not equal to 0. So this will go and return false. So this is how my is palindrome logic is working. If the number is palindromic, I'll get positive true. If the number is not palindromic, I'll go and get the false. Cool. Now let's talk to another important problem. Right? The next problem says that there are how many zeros? This is a very interesting problem. Trailing zeros in the factorial, उससे पहले factorial निकालना सीख लेते हैं. Quickly, let's try to solve a problem. Find the factorial of a number. A very simple problem. Let's try to quickly do this. I want you people to quickly try this out. If you're able to solve the problem, please paste your code in the chat section. Find the factorial of a number. What is the meaning of the factorial? Factorial of a number means that the factorial is 3. It should be equals to 3 into 2 into 1. If it is factorial 5, then it should be 5 into 4 into 3 into 2 into 1. I can also go and write 5 into 4 factorial. I can also go and write 5 into 4 into 3 factorial. Factorial of 0 is equals to 1. Factorial of 1 is also equals to 1. For negative numbers, we don't consider the factorials. So what is the factorial of a number? Factorial of a number is when you go and multiply from 1 till the n. So if I have to go and find the factorial of n, what is the logic that I have to go and apply? I have to quickly go and write 1 into 2 into 3 into 4 dot 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 n minus 1 into n. This is simple. Very simple code. I have to just write a loop and go and multiply all the numbers. I have to just go and write a loop, multiply all the numbers. Say for example, if I go and say that 5 factorial, I'll go and say that 1 into 2 into 3 into 4 into 5, and this should be my answer. So let's try to quickly write the code for this. So I like to write the both iterative as well as recursive. I'll expect you people to quickly write the code with me and just post that into the chat section. Let me go and open my code. And here I'll be go and comment this code also. Correct. Let me go and do this. Find the factorial of a number. So what we do? Function. I go and call it as fact number. And what I do is that I go and say that let I is equals to 1. And I go and say that while I is less than equals to the number. I also go and say that let result is equals to 1. What I go and do this? I go and say that result should be equals to result into I. And then I go and also go I equals to I plus 1. And then finally I should go and return result. Let's go and call this console.log and pass fact, and I go and pass 4. If I go and run this, node problems.js, the value is 24. Is that right? Let's try to see that. So I have a code here. If it is factorial 4, it should be 4 into 3 into 2 into 1. So it's 12 into 2 equals to 24, which is my answer. So my code is working perfectly fine. अब अगर मैं बोलूं, if you have to go and convert that into a recursive code, you have to go and convert that into the recursive code. How can I do it? It's again very simple, guys. Can you please quickly convert that into the recursive code? If I have to go and write the same code in recursion, how will I go and do it? I will go and say that function fact r, right? First of all, I go and write the base condition. What is the base condition? If number is equals to 0 or number is equals to 1, in that case, I should go and return 1. Else, what I go and do? I go and say that I should go and multiply number into, and I go and find the fact n minus 1. One of the most basic problem of the recursive approach. Let's try to go and call this. If it works, fine. So if I go and run this, okay, I got some error. What is that? N is not defined. It should be num, no? Num minus 1. So if I go and rerun this again, the value is 24. So my code here is working perfectly fine. So this is how I go and find the factorial of a number. Now a challenge problem comes in. It's a very interesting problem that we go and solve the next. So we have understood what is a factorial, right? Let's try to solve another problem, which I feel is a little challenging. I have to go and find the count of trailing zeros in a factorial. Find the count of the trailing zeros in a factorial. So it says that any number is given to you. Say that, for example, you have given a number called as 3 factorial. You have to go and say that how many zeros are there in the 3 factorial. So one of way of doing is that you first go and expand it. 3 into 2 into 1. This value will be 6. So the number of trailing zeros, will be equals to 0 here. Let's take another example. If I go and take the example of 5 factorial. So this becomes equals to 5 into 4 into 3 into 2 into 1. This will be equals to 5 for the 20, 20 is 60, 120. So the number of zeros here is equals to how much? 1. Similarly, let me go and say that 10 factorial. So one of the lame way of doing will be what? I am going to multiply all of them. I go and say that 10, 9, 8, 7, 6, 5, 4, 3, 2. So this whole value will becomes equal to 720. This whole value becomes equals to 210, and this value becomes equals to 24. Now I see that there are 2 zeros. So ultimately, if I go and multiply all of them, I will have something, something, something followed by 2 zeros. So the number of zeros is equals to 2. So like this, I could be given any big number like 3, 4, 6, 9, 8, and I go and do this. You have to go and tell me number of trailing zeros. How can I do it, people? So if you try to go and analyze it, if I go and find the 1, it's 1. If I go and find 2 time combinations, 2 into 1. If it is 3, then it is 3 into 2 into 1. If it is 4, then it is 4 into 3 into 2 into 1. If it is 5, then it is 5 into 3 into 2 into 1, which is equals to 30. It means that is 1, 0. Right? If it is 6 factorial, then it is 6 into 5 into 4 into 3 into 2, which is equals to 180, which is again equals to 10 only. If I go and do the 7 factorial, it's become 7 into 6 into 5 into 4 into 3 into 2 into 1, which is equals to 1260. It is again have 10 only. If I go and do the 8 factorial, it is 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1, which is equals to 0. It still has only one trailing 0. I'm only looking for the trailing 0, sir, right? 0, which is there in the end. If I go and make it as 9 factorial, I have 9 into 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1, which is equals to, which still has one trailing 0. If I make it 10, This becomes 10 into 9 into 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1, which is equals to 907200, and it has 2 trailing. Now, if you try to see this, this 10 could be broken down into 5 into 2. So here, till this point, from here till here, no 5, no 0. From 5 till 9, we have 1 5, we have 1 0. In 10, we have 2 5s, we have 2 zeros. Are you getting the pattern? So finding the number of zeros, right? Finding the number of zeros is equals to number of 5s in the given factorial. The number of zeros is equals to number of 5s in the given factorial. Am I clear, people? Does that make sense? So how do I find the number of 5? See, till the number of 10 factorial, number of 5s is equals to 10 divided by 5 is equals to 2. Till 20 factorial, the number of 5s will be equals to 20 divided by 5 is equals to 4. But when I become 25 factorial, number of 5s will be 25 divided by 5 equals to 5. Is this correct? Is this correct? In 25 factorial, the number of 5s will be 25 divided by 5. Is this correct? Or this is incorrect? This is where you have to go and apply the brain. See, if it is a normal number, for example, 15 factorial, right? So it will be equals to 15 into 14 into 13 into 12 into 10 into 9 into 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1, right? Now all the powers of 5, this is 1 5. Then this could be broken down into the 5 into 2, and this could be broken down into the 5 into 3. So total number of 5 is equal to what? 1, 2, and the 3. And you can also go and find it by 15 divided by 5 is equals to 3. When it is 20 factorial, let's assume that. So it becomes equals to 20 into 19 into 18 into 16 into 15, 14, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. So I have 1 5 here, right? I have 1 5 at this point. Then I have 10, which is equals to 5 into 2. Then I have 15, which is equals to 5 into 3. Then I have 20, which is equals to 5 into 4. So this is 1, 2, 3, 4. I can also go and get it by 20 divided by 5 equals to 4. But when I have 25, when I have 25 factorial, then how much? Then it is 25 into 24 into 23 into 21 into 20, 19, 18, 17, 16, 15, 14, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Now here in this case, I have 1 5 here. I have another 10 here. I have 15 here. I have 20 here, and I have 25 here. So 25 here is 5 into 5. 2 is 5 into 4. This is 5 into 3. This is 5 into 2. This is 5 into 1. So how many 5s? 1, 2, 3, 4, 5, 6. So here I have 6 5s. But if I go and divide 25 divided by 5, I will only have 5. So here in this case, the maths logic changes. That is not, see, in this case, it was 15 divided by 5 is 3. Here it was 20 divided by 5 equals to 4, just right. But when I put 25 factorial, I go do 25 divided by 5 is 5, but the actual number of 5s is how much? 6. Why it is happening? Because 25 is a perfect square of 5. So when it is a perfect squares, the perfect powers of the 5, it will come that many additional times. So typically, whenever you have the numbers like 25, 125, 625, which are the powers of 5, we need to take special care. Very nice. So what I need to do is that I'll just go and write that in the form of a code. Let's try to use this logic to go and write the code for here. So let me go to my VS Code. Code. Find the factorial. Find the trailing zeros in the factorial of a number. So I go and say that function, and I go and call it as find trailing zeros, and I go and pass n. First of all, what I'm going to do, if n is less than 0, in that case, I should go and return -1. Else, let me go and say that let count is equals to 0. And then I go and say that for let I is equals to 5. And then I go and say that math.floor. And then I go and say that n divided by I. And if it is greater than equals to 1, and then I go and say that I should get multiplied by 5. And then I go and say the count plus equals to math.floor n I. And then finally I should go and return the count. Fair enough. And let's try to test it. If it works, console.log. And then I go and find the trailing zeros. For 5, let's keep it for the 4. Then let's try to keep it for 8. Let's try to keep it for 25. And let's try to do the same thing for the 100. If I go and run this, it is telling that for the 4, the number of trailing zero is 0, which is correct. For 8, it is 1. For 25, it is 6. And for 24, it is 100. Let's try to copy this code and do a dry run so that, again, any doubt if it is remaining in your mind, it should get sorted. So let's put it here. Okay. And now what we do is, I go and call it as find trailing zeros. Let's try to find how do we find the trailing zeros in 100. So first of all, what happens? This is 100. Does not hold true. It comes here. The first I'm dividing. I value, initial value is 5. Math.floor n value is equals to 100 divided by 5, which should be equals to 20, which should be greater than equals to 1, right? So this count value becomes equals to count plus. So this count value becomes equals to now 100 divided by 5, which should be equals to 20. Fair enough. And the next time, again, the loop runs. Now, this time, I value has become equals to 25. And this becomes equals to 100 divided by 25 is equals to 4. And this I value, so here it becomes count equals to count plus 4. So this becomes plus 4. So this becomes equals to 24. Next time, the value of I becomes equals to 125. This condition does not holds true. So the total count value is equals to 24, which comes as the answer. This is the number of trailing zeros in the given factorial. Let me take one more example here, right? Say, for example, I want to do it for, let me copy this code here also. Once more, perfectly fine. Let's try to do the dry run of this. Let's say that I have a number called as 50. Let's say that I have a number called as 50. And I want to find the number of trailing zeros here, right? Now, if I go and do this 50s, what will happen? It will start with 50, 49, then it will have 45, then it will have 40. I'm just trying to find all the where the 5 will come. Then it will be 35, then it will be 30, then it will be 25, then it will be 20, then it will be 15, then it will be 10, then it will be 5, like this. And then 1, 4, 3, 2, 1. So in this case, what are the numbers where the 5 will come? This is 5, 50. This is 45, 40, 35, 30, 25, 20, 15, 10, 5. Now, how many 5s if I have to go and calculate? This 50 will have 5 into 5 into 2. This 45 will be have 5 into 9. This 40 will be 5 into 8. This 35 will be into 5 into 7. This 30 will be into 5 into 6. This will be 5 into 5. This will be equals to 5 into 3. This will be equals to 5 into 2. This will be equals to 5 into 1. Correct? So how many 5s are there? How many 5s are there? It is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Total number of 5s are 11. And how do I go and is it right? 5, 5, 25, 1, 2, 3, 4, 5, 6, 7, 8. Here also, no? 5 into 4. 9, 10, 11, 12. There are 12 5s, right? There are 12 5s. It means there will be 12 zeros. Another way of finding this number could be how much? I go and divide 50 by 5, which should be equals to 10. Then I go and divide 50 by 25, it's give me 12. Then I go and divide 50 by 125, so this will give me 0. So I stop it here. So total number of value will be 10 plus 2 will be equals to 12. This is the mathematics. For those people, first this maths is clear to everyone, guys? Is this maths clear? Is this clear to everyone? 76. Is this logically clear to you people? How did I go and find it? Let's take one more example. Let's take that the number is let's take the number is 45 factorial. So 45 factorial, what I'll have to go and do? I'll have to go and write as similarly, I'll go to the 30, 25, 20, 15, 10, 5, then 4, 3, 2, 1. Like this, it will come up, right? So what are the 5 factorials which are available is 45, 40, 35, 30, 25, 20, 15, 10, and the 5. So if I go and see this 45, I can go and write it as 5 into 9. This 40, I can go and write it as 5 into 8. 35, I can go and 5 into 7. This I can go and write 5 into 6. This will be 5 into 5. This 20 will be 5 into 4. 15 will be 5 into 3. 10 will be 5 into 2. 5 will be 5 into 1. If I go and find the total number of 5s, how much? 1, 2, 3, 4, 4, 2, 6, 7, 8, 9, 10. So how much number? 10 5s. It means that I have 10 zeros. Now, how can I find it mathematically? What I'll go and do? I'll go and divide 45 divided by 5. So this value will be equals to 9. Then I go and divide 45 divided by 25. This value will be equals to 1. Then I go and divide 45 divided by 125. This value will be equals to 0. So I'll not take this. The total number of values is 9 plus 1 is equals to 10, which is same as this. So how do I go and divide? Let's say that I have a number called n factorial. I have to find the number of zeros. So what I'll have to do, I'll have to first of all go and divide n by 5, n by 25 plus n by 125 till it becomes 0. This is the sequence that I'll have to do, right? The number of zeros will be always equals to n by 5 divided by n by 25 plus n by 125 till the time the value of this becomes equals to 0. Now the same logic I have put up here. So my code is this. Right? My code is this. In this part of the code, I'm just trying to do n by 5 plus n by 25 plus n by 125 da 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 da, and I keep on doing this till the time this value is greater than equals to. Let's solve one more problem and then we'll say it for the day. So the next problem is says that finding the HCF. So what we need to do, find the HCF or GCD of two numbers. Find the HCF or greatest common divisor of the two numbers. What does that mean? So let's say that I have two numbers like, for example, 36 and then 60. In order to find the greatest common divisor, what we do, we go and try to find the multiples of 36. So I go and say that 2 into 18, 2 into 2 into 9. I'm going to call it 2 into 2 into 3 into 3. Similarly, 60, I can go and divide into 2 into 30. I can go and say that 2 into 2 into 15. I can go and say that 2 into 2 into 3 into 5. Now, among this, I go and find what is the greatest common. So 2, 2, 3 is common from both of them. So the HCF or GCD of this will be how much? This will be equals to 12. HCF of the numbers. Can you guys quickly find me the HCF of a number called as, let's say I have a number called as 20 and the another number is 28. Can you guys tell me what will be the HCF of this? This HCF and GCD are the same thing. HCF and GCD are the same thing. Can you guys tell me what will be the HCF or the GCD of 20, 28? What should be? How do we find it? If I go and say that 20, it should be equals to 2 into 10. It should be equals to 2 into 2 into 5. And if I go and talk about 28, it becomes 2 into 14. It becomes equals to 2 into 2 into 7. So what is common out of these two? 2 into 2, 2 into 2. So the HCF or the GCD of this value will be equals to. Now let's try to solve this problem programmatically. Let's try to solve this problem programmatically. Let's think, first of all, whenever you get any problem, see, the art here is not to understand how to solve the parallel problem. The art here, my only intention in every problem that I'll go solve from today onwards is to awaken your brain, help you understand the thought process, that how do you think, how should you approach a problem. Your intention should not be to write the perfect code. You can always copy paste from somewhere and do it. The chat GPT can help you do that. Your process or your effort should be on awakening your brain, training your brain so that every time a new question comes in, you are still able to think. So every time you get a problem, try to think in a very raw manner. Your first intention should be that I should be able to solve a problem. So let's say that if I have a number something like this, for example, I have a number called as 6 and number 8. I have to go and find the GCD or HCF of the numbers 6 and 8. What I can do is, first of all, let's try to find what the minimum of these two numbers, minimum of 6 and 8. The minimum of 6 and 8 will be 6. So one thing is clear is that my HCF or GCD should be less than equals to 6. Do you guys agree with me? If I have two numbers, A and B, my highest common factor or GCD will be always less than the smaller number. Fair enough? Now what I do, if 6 divided by 6 is equals to 0 and 8 divided by 6 is also equals to 0, then I can say that 6 is HCF. But is it true? This is false. So 6 cannot be the HCF. So what I can do now is that I can go and try with the next smaller number, 5. Again do 6 ampersand 5 equals to 0. And 8 ampersand 5 is equals to 0. If it is true, then I go and say that 5 is HCF. But this is false. So 5 cannot be the HCF. So I again go down to the next smaller number, which is 4. Again go divide 6 divided by 4 is equals to 0. And 8 ampersand 4 is equals to 0. This is true. This is false. So this is also false. So again 4 cannot be the HCF. I go to the next smaller number, which is equals to 3. I go and say that 6 ampersand 3 equals to 0. This is true. And 8 ampersand 3 equals to 0. This is false. So this turns out to be false. I cannot be. Then I go to the next smaller number, which is equals to 2. 6 ampersand 2 equals to 0. True. And 8 ampersand 2 is equals to 0. This is also equals to. So this is equals to true. So my GCD will be equals to 2. So now what I have to do, I have to go and find the GCD, correct? So for finding the GCD, what we can do here is function GCD, and then I go and pass a comma b. First of all, I go and find the let result equals to math dot min. I go and try to find the minimum of the two values, which is equals to a comma b. And then I go and write while result is greater than 0. And I'm going to say that if a ampersand result is equals to 0 and b ampersand result equals to 0, then I should go and break and if not, I should go and result minus minus, and I should go and return result. Let's try to see if this works. So if I go into that console.log and I go and pass GCD and I go and pass 8, 6, 8, 9, 6 kar lete hain, and run this node problem.js. The value is coming out as 2. Similarly, if I go and give it like 36, 60, and I go and run this as the value is coming out as 12. We put that on a whiteboard and let's do a quick dry run so that it makes sense to us. Fair. So let's say that I want to go and do the GCD of 8, 6. Now when I go into this 8, 6, the result value will be equals to 6. Now here when I am first time and the while loop runs for the first time. In that case, the value of result is equals to 6. I go and do this. A is 8, A result is 6. This is not equals to 0. So I go and do the result minus minus. So while when it runs for the second time, the result value has become equals to 5. Again, when it is running for the second time, this value is 5 greater than 0, perfectly fine. A is 6, 5. This does not hold true. So I again come here. So third time when it is running, result has become equals to 4. So result now is 4, not holds. This holds true. So I come here. A is 6 ampersand 4 not equal to 0. I come here. So the next time it runs, while runs for the fourth time, the result is equals to 3. So again, this result is 3 equals to 3. 6 ampersand 3, this is true. And this is 8 ampersand 3, this is false. So again, doesn't hold true. So again, the fourth time when the loop runs, the result value becomes equals to 2. So now the result value is equals to 2. This is 6 ampersand 2. This is correct. This is 8 ampersand 2. This is again true. So this holds true. I do the break. So I come out here. The value of result here is 2. So it is returning 2 as the GCD. Now, this is the solution that you have given. But as soon as you go and write this code, because I know that you people aim us to make it big. Let's try to work for a big company. As soon as you go and provide this solution, let's say that you are sitting in an interview of Google and you provided this solution. As soon as the interviewer sees the solution, he says, no man, not interested. You are good for the tier 3, tier 4 type of companies, but you have to work for the top based product based companies like FANG. This solution is not good because this is order of n. Can we further optimize this? Can we further optimize this? Because this question might not be the way that you have solved it right now in a brute force manner. This might not be acceptable at the company's level like Google and Microsoft and LinkedIn. Yes, it will take more time. So how do we go and solve this? How do we go and fix this? We can go and fix this by using one of the mathematical concept called as a Euclidean algorithm. Euclidean was a very famous mathematician. He said that, let's say there are two numbers A and B, right? And its HCF value is, say, for example, G. If we subtract smaller from bigger, GCD does not change. Euclidean, the great mathematician, said that if there are two numbers and if you subtract a smaller number from a larger number, it will not change the HCF of the resulting numbers. What I mean to say that, let's say in the beginning it is A comma B and the HCF is G only. Now let's say that this is the larger number and this is the smaller number. If what it say that A minus B and C, its HCF, A minus B and B HCF will also be G only, it will not change. This is the Euclidean algorithm says. This is what the Euclidean algorithm says, that if A and B has a GCD equals to G, A minus B, if you go and subtract the smaller from the larger number, then also the GCD remains the same. This is a theorem which you should be aware. It's a Euclidean algorithm. Let's try to see if it works. Let's say that I have two numbers called as 36 and 60. With our method, we know that the GCD was 12. Let's try to find it using the Euclidean's method. So I have 36 and I have 60. This is smaller and this is larger. So what I can keep, I can say that 36 comma 60 minus 36, which is equals to 36 comma, and this becomes equals to 24. Now this is smaller and this is larger. So I can go and say that 36 minus 24 comma 24. So this becomes equals to 12 comma 24. And then again in this case, this is smaller and this is larger. So again I can go and say that 12 comma 24 minus 12, which is equals to 12. So it becomes 12 comma 12. So when both of them becomes equal, GCD is 12, which is same. So I'm able to find the GCD using the Euclidean's algorithm. Am I clear, people? Does it make sense? Is this clear to everyone? How did I find it using the Euclidean's algorithm? Let's take another example. Let's say that, for example, I have 6 and the 8. I want to go and find the GCD. What is the smaller of 6 and 8? So I go and say that 6 comma 8 minus 6, which is equals to 6 comma 2. Then what I go and do? I go and say that 6 minus 2 comma 2, which is equals to 4 comma 2. Then again what I go and do? I go and say that 4 minus 2 comma 2, which is equals to 2 comma 2. When both are same, then this is the 2 is the GCD. Where? Clear? Chamka? Is it clear to everyone, guys? Now I just have to go and make use of this logic, and now it becomes Fang types logic. Now it becomes the Fang type logic. So what I go and do now is I'll go to my code, and here let me go and find the GCD. So I go and call it as function GCD optimized, and in this I go and take two numbers, a comma b. Yeah. If a is equals to 0, then I should go and return b. If b is equals to 0, then I should go and return a. If a is equals to b, then I should go and return anything, a or b. Else if a is greater than b, then I should go and call this function recursively, return GCD optimized. And I can say that a minus b comma b, else return GCD optimized, and I go and say that a comma b minus a. Can you see this function GCD 0, a 0, return b, b 0, return a equals to b, return a greater than b, then you do this, else you go and do this, right? Let's try to go and run if it works, GCD optimized. If I go and run this, it's working perfectly fine. Let me take this question, bring it to my whiteboard, right, and put it here. Right. The logic which I have used here, which has made it more optimized here, is again coming from the Euclidean's algorithm. Perfect. We'll get started with the very first problem, which is finding the LCM of two numbers. Right? What we want to do, we want to find the LCM of the two numbers. What is the LCM? LCM stands for the lowest common multiple. Right? LCM stands for the lowest common multiple. What is the meaning of the LCM? Let's say, for example, I have two numbers. For example, I have a number called as a 15, and then I have a number called as 20. If I have to go and find the LCM of 15 and 20, can you guys tell me what will be the LCM of 15 and 20, people? 15 and 20, what will be the LCM? Can you guys try to go and find it? So now, can you guys tell me what will be the LCM of 15 and 20? In order to find the LCM, what we normally do, let's say that I have a number called 15. What I'll do is that I'll go and try to find the prime factors of 15. What that means, the prime factors of 15 will be 3 into 5. Then I have 20, I will go and find the prime factors of 20. So it will be 2 into 2 into 5. Now once I do this, what I normally try to do is that I go and try to find the union of these two prime factors. Union of these two prime factors. So union of this will be 3 into 5 into 2 into 2, and the value will be equals to 15 into 4, which will be equals to 60. Fair enough. So the LCM of these two numbers, the least common multiple of 15 and 20, will be the 60. If I go and talk about 5, the common among these two is 5. So 5 is the HCF. So HCF value is equals to 5, and LCM, which is the least common multiple, this value will be equals to 6. This will be the answer. एक और example लेके देखते हैं. Let's try to take one more example. Let's say that another example is my number A is equals to 15 and B is equals to 25. Can you guys tell me what will be the LCM of this? What will be the LCM of A equals to 15 and B equals to 25? Can you guys please quickly tell me what will be the answer of this? So again, it's very simple. I go and take the first number A equals to 15. Now 15 I go and express in the form of a prime factor. So I'll go and say that 15 value should be equals to 3 into 5. B is equals to 25, which is equals to 5 into 5. Now if I have to go and find the HCF, I'll find the common. What is the common among these two? Common is 5, so HCF will be 5. And what will be the LCM? LCM is basically the union. If I have to go and find the LCM of this is the union. So it will be 3 into 5 into 5. So answer should be equals to 75 is the LCM. So the question says that this is what I go and do it manually. Is everyone clear how do we find the LCM manually? Is everyone in the class clear around that how do we find the LCM of the two numbers manually? Perfect. So now what we need to do is we have to solve this programmatically. We have to go and write the code for solving this problem. How I can programmatically go and solve it? What should I do so that I can programmatically go and solve this problem? So in order to solve this problem, let's try to analyze this. If I have two numbers A and the B, what is my HCF? HCF is basically the common factors, which is greatest. Right, that is HCF. And what is LCM? LCM is basically the largest multiple. So if there are two numbers called A and B, normally there is an expression that A into B value should be equals to LCM of A comma B into HCF of A comma B. This is a mathematical theorem, boss. What is a mathematical theorem? If there are two numbers A and B, the product of the two numbers A and B is equals to the product of LCM of A and B and HCF of A and B. Let's try to see if that is true. So let's say that I have two numbers called as 10 and 15. Now 10 is equals to 2 into 5, 15 is equals to 3 into 5. So my HCF value will be equals to 5, LCM value will be equals to 2 into 3 into 5, which is equals to 60. Now my hypothesis was A into B should be equals to LCM into HCF. Let's see if it is true. Left hand side, A into B will be equals to 10 into 15. LCM is equals to what? 60. HCF is how much? 5. This 10 into 50. Have I found the LCM correct? It's 2 into 5. Is this relationship coming correct? Have I done any mistake? 10 is 2 into 5, 15 is 3 into 5. HCF is coming out as the highest common factor, which is 5. This is right. LCM is 3 to the 6. It is 30. No, it's not 60. I have done a mistake here. This is 30. right? So let me go and correct this. This should be equals to 5 into 30. So if I go and see that this right hand side value is also equals to 150, A into B is also equals to 150. So this expression A into B is equals to LCM into HCF is a right, we can see that. So in our previous problem, we know how to find the HCF. We know how to find the product. So if I have to go and find the LCM value should be equals to the product divided by HCF of A comma B. That should be our answer. So using this logic, I can go and solve the problem of finding the LCM. So let me quickly open my VS Code. And my VS Code, the last problem which we did in the last session, right? If you guys remember, the last problem which we did in the last session was GCD itself. Right, the last problem was the GCD itself. Let me increase the font. And this is how we define the GCD. Right, GCD was, this was my function that we go and define. GCD optimized. Now using this code, I'll go and try to find the LCM. So what I'll go and do is that let me go and define a function called as function. And I go and call it as LCM. I take two numbers A comma B. Okay. And then what I go and should return, the LCM should be equals to A into B divided by whatever is the GCD optimized, and I go and pass A comma B. That should be my code. I just go and copy this. Let me go and put that on my whiteboard. So this should be my code. Very simple and the sleek. The LCM of a number will be that you go and find the product of these two numbers and then find the GCD. GCD we already did in the last session. Fair enough. Am I clear, people? Does it make sense? Aage badhe. Let's take one interesting problem. So this was the question which was asked from me when I was joining LinkedIn, right? So when I was interviewing for LinkedIn, this was a mathematical puzzle which was asked to me, and I want you guys to give it a try. The question says that there are 100 doors. The question says that there are 100 doors. For example, there is a door 1, door 2, door 3, door 5, door 6. Like this, I have door 98, door 99, and I have door 100. The initial position of all the doors are that initially all the doors are closed. C is representing that all the doors are initially closed. Okay, this is the initial position at time t equals to 0. All the doors are initially cooled. Now what happens? You start from the first door. You start from the first door. You start from the first door. And if it is closed, you make it open. And if it is open, then you make it closed. So you start from the first door and you go to every door. So you make every door open. Like this, you go open, open, open. First time. Second time, you start from the second door. And if it is open, then you make it close. And if it is closed, you make it open. So it is open, you make it close. You make it close. So you go to every second, fourth, sixth, 8th, 10th, like this you go and do, right? You make it closed. Third time you start from the third door and if it is open, you make it close. If it is closed, then you make it open, and like this you keep on moving. You toggle the door, and like this you continue doing for 100 times. I am repeating the question again, sir. Please watch it very carefully. It's a very interesting problem. There are 100 doors, one after the another, right? D1, D2, D3, D4, D5 till D100. These are the 100 doors. Initially, all the door is closed, boss. Darwaja band hai. Now all the doors are closed at time t equals to 0. Now first when you start, the first time you go to each of the door, since it is closed, you open it. So you go to each of the door, you go door 1, door 2, door 3, door 4 till door 100 you go and you open all the door. Next time you start from the door number 2 and then you go to the door number 4, then you go to the door number 6, and in this time if it is open, close it, if it is closed then open it, just flip the door. Next time start from the door number 3 and then go to the door number 6, then go to the door number 9 and you do the same thing. If it is closed, open it, open then close it. Next you go to the 4th door. Next time you go to the 4th door, then 8th door, then 16th door. Like this you go and repeat this exercise for 100 times. After 100 times, once you are done with it, can you guys tell me that how many doors are still closed? How many doors are still closed? Can you guys, I'm giving you 2 minutes of time to think over it and try to please solve it. So you can either tell me that how many doors are still closed or how many doors are open, either of these things, right? You can tell me that after 100 times which all doors are open. See, I am repeating the question again. Those people who have not understood it, I am repeating the question again slowly. There are 100 doors, 100 दरवाजे हैं, there are 100 doors, door 1, door 2, door 3, door 4 till door 100. First time when you go to all of the doors. Since it is all closed, you open all the door. Second time you start from the door number 2. If it is open, close it. If it is closed, then open it. Third time you start from the door number 3. If it is closed, you open it, otherwise you go and close it. This you have to repeat 100 times. Just to explain you, let's take a small case, right? Let's say that I only have door 10, door 1, door 2, door 3, door 5, door 6, door 7, door 8, door 9 and door 10. Let's say there are only 10 doors. So the very initially everything is closed. Now the first time when I ran for the first time, so all the closed will be, I'll go and open all the door. I'll run and open all the door. Second time when I go, I'll go start from the second. So this open, it is open, so I make it closed. It is open, so I make it closed. This is open, so I make it closed. This is open, so I make it closed. Sorry, this is even open itself. 8, open, I made it closed. This as it is. 10, I make it closed. Third time, I will start from where? Here. So this remains as it is. This is open, so I'll make it close. This remain as it is. This remain as it is. This is closed, so this became open. This remain as it is. This remain as it is. This is open, so it becomes closed, and this becomes open. Sorry, this remains as it is. Fourth time, I will start from the fourth here. So this is C, so I'll make it O. Before this, everything remains same. After this, C, O, O. This C is again divisible by 4, so I go and make it as O. And this remains C, this remains C. Fifth time, I'll start from the fifth. This is C, so I make it O. Previous this, I remain as it is. And then 0, closed, closed, closed. D, C is closed, I go and make it open. Next, sixth time, I'll start from the sixth. This is open, so I'll make it close. Before this does not make any change. And then it remains as it is. Seventh time, I go to the seventh. It's open, I make it close. Everything else remains same. Eighth time, I start from the eighth. I make it closed. Everything else remains as it is. Ninth time, I go to the ninth. Make it closed. Everything remains as it is. Right? And then the 10th time, I go to the 10th and make it closed, and then everything remains as it is. So after 10th time, if I go and ask you which all things remain open, So this door 1 is open, door 1 remains open, door 4 remains open, right? And door 5 remains open. Am I correct? Is it making sense? No, door 5 will also remain closed only. I think here I did the mistake. When I did the 3, this should be opened only, right? This remain open only, open. And at this 5th time it should become closed. So this will be also closed. So typically, when I go and do this, D5 is also D4, D1 and D4. These are the only things which will remain open after this. Am I clear with you people? Is the question clear to everyone? Now let's try to think that how do we go and solve this problem. Let's try to think that how do we solve the problem. Now if I go and talk about any door, let's say that I go and talk about any door, what we are trying to do, it is initially closed, then we are opening, then we are again closing, then we are again opening, then we are again closing. Like this the event is happening, right? So if the door is initially closed and if I go and do the even number of operations, if the door is initially closed and if I do the even number of operations, then after even number of operations, will that door remain open or door remain closed? The question for you is, if initially the door is closed and I end up doing the even number of operations on the door, will the door remain open or door remain closed? What do you guys think? What will be the state? Say for example the door is, this is the door, it is initially closed. Now if I do even number of operations, let's say that even number of operation is equals to 2. So I became, C becomes open and then I became closed. So if I do even operation, it again becomes closed. Agar if this is 4, so this is opened, then closed, then opened, then again closed. So when you do the even open number of operation, if it is initially closed, it will be closed only. And if I do the odd number of operations, then what will happen? It will come in the open position. Am I clear with this logic? The door is initially closed and I do the even number of operations, the door will be closed only. And if the door was initially closed and on that door if I go and do the odd number of operations, it will end up staying open. Fair? Now coming back to this problem, I have door 1, door 2, door 3, door 4 till door 100. Okay. First time I am going to all the 100 doors. Second time I am starting from second and I go to every second door. Third time I am starting from third and I go to every third door. Fourth time I am starting from fourth and go to every fourth door. Like this I am continuing, right? This is how the sequence will be. Now if I go and ask you, if let's say for example if I go and ask you door number 20, if I go and ask you door number 20, how many times it was flipped? Can you guys give me the answer? Can you guys tell me the door number in this whole 100 exercise, when I go and do it for 100 times, how many times door number 20 would have been flipped? Can you guys tell me the answer? Can you think of how many times the door 20 would have been flipped? See, door 20 would have been flipped when I was running the first time. Door 20 would have got flipped when I was running the second time. Door 20 would have got flipped when I am running for the fourth time. Door 20 would have got flipped when I am running for the 5, and door 20 would have got flipped when I am running for the 10, and door 20 would have got run when I am running for the 20. Fair enough? Does it make sense to you people? So how many times door 20 would have got flipped? 1, 2, 3, 4, 5, 6. 6 times? 6 times, no? Door 20 would have got flipped when I started with 1. Second time, because second, 4, 6. Fourth time. So all these numbers which can divide 20. So how can I find it? All the numbers which will divide 20 that many times? Right? All the divisors of 20. How many divisors of 20 are there? 1, 2, 4, 5, 10, 20. Similarly, if I go and ask you door number 60, how many times it would have been flipped? Can you guys tell me the answer? How many times door number 60 would have been flipped? So if you go and find the door number 50 to be flipped, I will consider 1, 2, 3, 4, 5, 6, 10, 15, 20, 30 and 60. Right? All these are the divisors of 60. So when first time, second time, third time, fourth time, fifth time, sixth time, 10th time, 15th time, 20th time, 30th time, 60th time, how many this is there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Am I missing anything? There should be 12th also. Right? So it will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this will be happening how many times? 12 times. And if it was done 12th time, door 60 will be open or close? Open or close? If I do it 100 times, door 60 was initially closed. So after 100 attempts, it will be open or closed, sir? It will be closed. So which all doors will be open? If I have to go and answer a question, which all door numbers will be open? Only door numbers will be open whose number of factors are odd. Because all those door numbers whose factors are even, they will remain closed only. Only those doors whose factors are, number of factors are odd, those doors will be open. Can you guys get this logic? Those doors whose number of factors are, those door numbers whose number of factors are odd will become the open. Who will be those door numbers? What will be those door numbers? So all the numbers which are perfect square. What is the perfect square? Square of a number, whole number. For example, if I go and take a door number called as 25 and I go and find what are the number of factors of door number 25, it will be 1, it will be 5, it will be 25. The number of factors of 25 is how much? 1, 5, 25, which is odd. So if it was initially closed, at the end it will be what? Open. Take any other number. For example, 4. 4 is a perfect square. If I go and take the number of factors, it will be 1, 2, 4, which is again odd. So when I go and flip it for the odd time, if it was initially closed, after that it will be open. So what we need to find? We need to find that from 1 to 100, which all door numbers are perfect square. If I go and find that from 1 to 100, which all door numbers are perfect square, I am done. So what will be those numbers? It will be the door number 1, then it will be 2 square, then it will be 3 square, then it will be 4 square, then it will be 5 square, then it will be 6 square, then it will be 7 square, then it will be 8 square, then it will be 9 square, and then it will be 10 square. So these are the door numbers, which means that door number 1, door number 4, door number 9, door number 16, door number 25, door number 36, door number 49, door number 64, door number 81 and door number 100 are those door numbers which will be open. Maza aaya? Is it making sense to you people? Is this point clear? This is a very beautiful problem which uses a concept. Only perfect square has even number of factors. Please note it down in your diary. This is an important concept. This could be in the interview, Guma Firake, people can go and ask you this question. Only the perfect squares has even number of factors. Everyone else, every other number in this world will have the odd number of factors. Sorry. Only perfect square is, मैंने उल्टा बोल दिया, has the odd number of factors. Only the perfect squares has the odd number of factors. Every other number will have the even number of factors. So if I have to go and find all the open door numbers, what I need to do? I just need to go and print these numbers. So let's quickly go and write the code for this. How do I go and write the code for this? So I'll go and open my code. And let me go and comment out all these codes which we have written previously. So I go and define a function and I go and call it as print door, print open doors, right? And then the number is num. How many doors that I want to go and do it. Okay. So what I go and do is that for I and then for I equals to 1, I is less than 100. Or I can go and say that, for I is less than 100, that's perfectly fine. I plus plus, or I think it's better that, I can go and write a while loop here. So I go and say that let I is equals to 1, while I is less than 100. What I go and do that, I go and print this console.log. I print I. And then what I go and do that, I go and say that I into I equals to 100, and I go and do this I plus plus. Correct, and this should be my answer. This should go and print me all the open doors. If I go and copy this here, this should be my this is a simple code. So if I go and try to do the dry run, right? So in the very beginning, when I'm starting, I value is equals to 1, 1 is less than equals to 100. So what will happen, this will go and print 1. Then this becomes equals to 2. So 2 into 2, 4 is less than 100. So I go and print 4. Then it becomes 3. So it becomes 9, 9 is less than 100. So it goes and prints 9. Then it becomes 4. It becomes 16 is less than 100. So it goes and prints 16. Then it becomes 5. 25 is less than 100, so it goes and prints 25. Then it becomes 6. 36 is less than 100, so it goes and prints 36. Then it becomes 7. 49 is less than 100, so it prints 49. Then it is 8. 64 is less than 100, so it prints 64. Then it becomes 9. 81 is less than 100, so it prints 81. Then it becomes 100. 100 is less than equals to 100, it prints 100. And after that it becomes 121 and this breaks. So these are the doors which will be open. These are the doors which will be open. Am I clear, people? Now a common question which the people have said, that a common question, sometime you go and make use of for loop and sometime we normally go and make use of while loop. How do I decide that when should I go for the for loop, when I should go for the while loop? Now there is no much great difference. Ideally everything that you can do with the for can be done with the while also. But one thing which I normally follow, the approach is, when you know how many times the loop is running, when you know the fixed number of times that I want to go and run for 10 times, I want to go and run for 100 times, I want to run for 121 times, when you know the number of times, go with the for loop. When you're trying to run the loop based on the condition, you're not sure how many times I want to run it. It's based on condition. Till the time the condition is there, I keep on running. Till the time C is telling me that I'll come on a date, I'll keep on trying, right? So in that case, if the condition is maintained, then I go and make use of while. So based on the condition, I make use of while loop. If it is number of times I know in the beginning, I go and make use of for loop. Now let's try to move to the next question. The next question is very interesting and there are a lot of problems which comes in the market from this concept. What is that next concept? The next concept is called as concept of a prime number. Right? So first of all, let's define that what is a prime number. A prime number is a number which is only divisible by 1 or that number itself. What is a prime number? Prime number is a number which can only be divisible by 1 or the number itself. For example, 11. 11 is a prime number because it can either be divided by 11 or 1. 7 is a prime number because it could be only divided by 1 or this 7. On the other hand, if I go and talk about 6, 6 can be divided by 1, it can be divided by 2, it could be divided by 3, it could be divided by 7. So it can be divided by more than 1 and 6. So it is not a prime. A prime number is a number which can only be divisible by either the number itself or it could be divided by 1. That's the whole concept. You cannot have a prime number which is divisible by more than 2 numbers, right? So first concept of the prime number is that every prime number is divisible by only either 1 or the number itself. Fair enough? Am I clear, people? Does it make sense? Now, few of the facts. If I go and talk about 1, see all the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9 like this if I go and talk about. In this 1 is neither prime nor composite. So all the other number, for example 4 which is equals to 1 into 2 into 4, these are the factors. These are termed as the composite numbers. Right? Those number 5 are considered as the prime number because it only have 1 in the 5. This is a prime number. But 1 is a special number which is neither prime nor composite. 1 is not considered as a prime or a composite number. Okay? This is a basic maths concept which you would have studied in the school. I just wanted to keep the quick revision. A question for you people. Another interesting fact about the prime number is that 2 is the only prime number which is even. There is no other prime number in the world which is even. Only prime number which is even is 2. Only prime number even is 2. Okay? So now the question comes. The question comes that you have been given a number n. It says that, dude, I have given you a number n. You have to go and tell me, is n a even number? The question is, given a number n, can you come and tell me if n is a even number? Given a number n, if n is an even number, how do I go and find it? Let's say that I have a number which has been given to me, for example, 28. Just to check if this number is a even number, sorry, not an even number, prime number, yeah, what has happened to me, is a prime number. To check if a number is a prime number or not, one of the most basic way that I can do is, I can start checking. First of all, I go and check with 2. If I go able to go and divide by 2, I go and say that 28 is divisible by 2, so it's not a prime number. Let's take another number called as 23. I want to go and check if 23 is a prime number or not. So what I'll go and do and check with 2. If I'm able to divide by 2, no. I'll check with 3, no. I'll go and check with 4, 5, 6, 7, 8, 9, 10, 11, 12, none of them are able to divide it. 14, no. 15, no. 16, no. 17, no. 18, no. 19, no. 20, no. 21, no. 22, no. 23, yes. So I'm able to divide with 1 and I'm able to divide only with 23. So 23 turns out to be a prime number. So this is one of the most basic way or the rudimentary way of finding if this number is a prime number or not. Let me go and write the code, and you should also try in the parallel that how we go and write the code for this. So I'll go and open my Eclipse, not Eclipse, code, because I've been writing things in the code. And now what I'm going to do is, let me go and comment this out. And then I go and write here as function, and then I go and find that is prime. This number. If number is equals to 0 or number is equals to 1, in that case this is not prime, boss. So I go and return false. If number is equals to 2, it means that it is a prime number, so I go and return true because 2 is a prime number. Otherwise, what I go and do is for I equals to 2, I value is less than equals to n I plus plus. If I find a number which can divide this n, if n ampersand I is equals to 0, then I go and return false. Else, after the for loop, if I am not returning the false, I go and return true. Right? This is the whole logic of writing the print number. Let me go and copy paste this and put that on my blackboard. This is how it is looking. So if I go and define this as is prime and the value is, say for example, 10. So n value is 10, n value is 10, does not hold true. I come here, n value is 10, not hold true, come here. I value is equals to 2, n value is equals to 10, 10 ampersand 2 is equals to 0, true. So this will return that no, it is not a prime number. Let's try to run it for another test case, which is prime and I go and check the value as 7. Right, so n value is equals to 7, n is 7, n is 7, does not hold true, does not hold true, I come here. N value is equals to 7, does not hold true, I come here. I try to go and divide first, the I value is equals to 2, this does not hold true, again comes back. Then I value is equals to 3, 7 ampersand 3 does not hold true, again goes back. I value is equals to 4, 7 ampersand 4 does not hold true. Then 5, 7 ampersand 5 does not hold true. I equals to 7 ampersand does not hold. So this whole for loop is done, I does not return anything, so I go and return 2. So this returns out as 2. So this is a very basic code that I have written for finding if the number is prime or not. What will be the time complexity of this code, sir? Can you guys tell me what should be the time complexity of this code? What would be the time complexity of this code, sir? The time complexity here will be depending on n, that many times the for loop is running, the time complexity will be equals to order of n itself, which is the linear. If you go and solve this problem for the basic companies, for the startups, low startups, they will be happy, okay, they will say that okay, good, you have been able to write the code. But if you are aiming to target the FANG companies and you go and show this code, they will say that you need to work better. So I need to go and optimize this code. I need to go and optimize this code. If I have to get into the FANG companies, MANG companies, I have to go and optimize this code. How I go and do it? Now if I go and take the example of this code, let me go and paste the code itself here again. What is my input size here? What is my input size? N is the input size. What is the operation? Number of operation is the number of times the loop runs. How many times the loop will run? The loop will run is equals to number of operations. And how many times the loop is running? Number of operations is running n times. So the time complexity will be kya? Order of n. Fair enough. This is how we go and do it. All those people who was feeling clueless, the first video on my this channel, Vishwa Mohan, you'll go and find the time complexity wala. Time complexity. I have very detailed way, I have explained all the possible cases. Please go and watch this time complexity video, which will help you get clarified. I'll strongly suggesting all of you people who is actually interested in the data structures and algorithm, make sure that you're not missing this concept. Please go and watch that. Now coming back to the code which is there in my hand. Right? Its time complexity is order of n, which is not great. My interviewer is saying that optimize this. How can I optimize? Optimize means this loop which I am seeing here, its number of loops or iteration should be reduced. The number of iterations should be reduced in this case. I should not go and run for the n times. If I have to optimize it, I'll have to reduce it for the n times. How can I do it? Sir, if you have any number num, and let's say num is equals to the product of two numbers a and b. If I have any number num which is equals to the product of two numbers a into b, if first number is greater than square root of this number, then b has to be less than the square root of a number. Do you guys agree with me? If there is a number which could be represented in the form of the product of two numbers a and the b, if a is more than the square root of the number, the another number b has to be less than the square root of the number. Fair, right? Because if a and b both are equal, then it should be equal to the number. So what this means is that if I have a number n, and if I can from the 2 till square root, if I start from 2 if I start from 2 and go till square root of n, I don't find a divisor, then there is no divisor. If I start from the 2 and go till square root of n, see, any number n is a into b. If a is less than square root of n, then b has to be more than the square root of n. So till square root of n, if I don't find any number, so if I don't find any number which is less than square root of n, it means there is no number also available more than square root of n. What I mean to say is from here is that if no divisor is present till square root of n, then there will be no divisor present till square root plus 1 till n also. Is this point making sense? See, I'm again trying to explain. See, let's say that I have a number n. Okay, na? N could be always expressed as a multiple of a into b. Okay, na? There could be two scenarios. A value is equals to root n and b value is equals to root square root n. Then this becomes equals to a into b equals to n. This could be case 1. Or the other case could be that one value, a value is more than square root of n, and then b value should be less than equal to square root of n. Because if it is a little more, then it has to be little less. Correct? So now, based on this condition, I am trying to say that, let's say there is a number n. If we start from 2, 3 and I go till square root of n, and till this point I find no number which can divide n, then in that case from square root n plus 1 till n there will be no divisors as well. Does this point make sense to you people? Let's try to take with an example, okay? So, for example, I have 6, right? If I go and take the square root of 16, this value will be equals to 4. So if I start from the 2 and I go, if I start from 2, 3, 4, 5, start from 2 and I go till 4, I go and see that there are multiples. 2 is a multiple, 3 is not a multiple, and 4 is a multiple. So when I have a multiple in less than 4, after the 4, like 5, right, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So when if I have less than square root 4, I have the value. I will have also after that, because after that if it is, then it will be 8 will be the one, 16 will be the another one. But on the other hand, if I go and talk about a number like 17, right, the square root of 17 will be 4.13, something of that sort. Let's assume that. Okay, so numbers which is less than 4.13 is 1, 2, 3, 4, right, and this is my 4.13. Now I have to start from the 2 itself. Now since 2, if I try to go and divide by 17, not possible. Can I divide 17 by 3? Not possible. I divide 17 by 4, not possible. So if I am not able to divide by any number less than root 17, after these numbers will also, I will not find a single number. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. I will not be able to find any of these numbers from here till here also. This is what this statement is trying to say. So what this condition is trying to say is that the previous code that I have written, the previous code which I have written, which if I go and paste it here in this case I have run the loop till square root of n. I can go and actually optimize and run this route only till square root of n, and then also I should get the correct result. Because if I can't find a number which is less than the square root of n and can divide the n, I know that it is a prime number, right? So either I can do this, or so what I can do is that I can go and write something like this. I can go and say that code, and I can just make changes here. I can say that I square is less than equals to n. I square is less than equals to n. This is the more optimized code. This is the more optimized code. So the optimized code of this version will look something like this. So what will be the time complexity of this? What will be the time complexity? The time complexity of this is that, what is time complexity? Is the number of operations is proportional to input size. This is the time complexity definition. This is my input size. Number of operation is how many times this loop executes, right? So let's say that this loop executes k times. Let's assume that loop executes k times. So when the loop is terminating, I'll go and say that k square will be proportional to n. So I can go and say that k is proportional to the square root of n. K is my number of operations and n is my input size, right? So the time complexity of this problem will become equals to order of square root of n. So the time complexity of this optimized solution is order of square root of n, and this code will help me understand if the even number is prime number or it is not a prime number. This is a very important concept. I have seen mostly the people who are doing coding for the first time, they struggle to understand this concept. This is the beauty of YouTube. You can always go back, replay the questions and solve it, right? So आप लोगों को, everyone who have understood this, pat your back. Can you please put that into the comments? Who all of you have been able to understand this? If not, there's nothing wrong in it. 70% of the students that I have taught for the first time, they have not been able to get this contest, but most of them have been able to go through the Google interview and crack it, provided they have been consistent. Okay? So even if you're not able to solve it, you don't have to feel demotivated. You're just getting started. But make sure that you watch it 10 times if it is needed, but your concept is getting crystal clear. The next question becomes at the top of the previous question, right? The next question says that if I give you a number n, if I give you the number n, what do you need to do? You need to go and print all the prime numbers smaller than n. The next question says that if I give you a number n, for example, I gave you a number called as 10. I gave you a number as a 10. What do you need to do? You have to go and print all the numbers, right? Let me write the problem statement. So the question is print all the numbers, all the prime numbers smaller than the given number. Print all the prime numbers smaller than the given number. So for example, if I give you the number 10, all the prime numbers smaller than 10 are, which are those prime numbers? So the value will be 2, 3, 5 and 7. If I go and say that the number is 20, all the prime numbers smaller than 20 will be 2, 3, 5, 7, 11, 13, 17, 19. For a human brain which is very smart, this looks very simple. But I have to find an algorithm so that I can go and print it. I have to go and find the algorithm to print it. Am I clear with the question? So one of the naive approach, right? One of the naive approach said that I have to go and print all the prime numbers less than 10. Right? If I have to go and print all the prime numbers less than 10. See, one of the naive approach, see, you should always try to come up with some approach. It's okay to start with a very basic naive approach, but your first approach should be, I should be able to solve the problem. So if you try to think humanly, what should I try? One approach which is hitting my mind right now is that if I have to go and find all the prime number less than 10, what I can do is that I can start with the numbers. For example, I first start with the number 1. And then I say that, okay, I go and check if it is prime. And then it says it's not a prime number. Then I come with the number 2. I go and check for the prime and the number is prime. So I go and print 2. Then I come with the number 3. I go and check if it is prime. The number is prime. So I go and print 3. I come to the number 4. I check if the number is prime. I get no. So I don't print the number 4. Then I print 5. Then I come to 5. I check the number if it is prime. Yes, it is prime. So I go and print 5. I come to the number 6. I check if it is prime. Yes, this is not prime, so I don't go and print it. I come to the number 7. I check if it is the prime. Yes, it is the prime, so I go and print 7. I come to the number 8. I check if it is a prime. It's not a prime. I come to the number 9. I check if it is the number prime. No, it's not the prime. So all the numbers less than 10, what are those prime numbers? It is 2, 3, 5, 7. So I'm able to print it. This is the basic approach of printing all the prime numbers. This will be the basic approach of printing all the prime numbers. Right? And what will be the pseudo code for it? So the code should look something like this. Function. Let me write the code in here and I'll put it up here. If I go and write with this approach, let me go and open my code. And function print primes, and I go and say that n for for I equals to 2, I is less than n, I plus plus, and then I go and say that if is prime, and I go and pass this number I, and if it is this, then I go and console.log, and then I go and write I. Like this, I go and write the code. So this will be my code, the logic which I just talked about. The code looks something like this. Fair enough. This is the first version of the code, version 1. This is the version 1. And what will be the time complexity of this? I know that this is gonna run for n times, and this is prime has a time complexity of at least square root of n. So this overall time complexity of this problem becomes equals to order of n square root of n. The overall time complexity is order of n root n. The overall time complexity is order of n root n. What is the more optimized solution of this? What is the more optimized solution of this? So a more optimized solution of this is as an algorithm, and I'm not expecting you people to know this. So you have to just know this algorithm, take a notebook, note it there, write it down, because that will help you find this, print this prime number less than n in a very optimized manner. Right? That theorem is called as sieve of Eratosthenes. Eratosthenes. I might would have done some spelling mistake because this is a very tongue twister name. So if I have done it, please don't mind. You can go and check on the internet the exact spelling of it, but it's called sieve of Eratosthenes. Right? It is an algorithm which tells us how to find the prime numbers less than n in an efficient way. Right? How do we do it? Let's get started. So what we do in this case is, let's say that n is equals to 10. So first of all, what we do, we keep an array of the number 10. So we go and say that 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we always start from the 2. So first we start from the 2. So we start from the 2, and all numbers which is divisible by 2 and greater than square of 2, which is equals to 4. So all the numbers which is divisible by, so the first number is 2, so a number which is divisible by 2 and also it is greater than square of 2, all those numbers I have to go and cut. So what I go and do is that I go and cut 4, I go and cut 6, I go and cut 8, and I go and 10. Then I move to the right and find the first number which is not cut. So the first number which is not cut is 3. So I go and say that all the numbers which is divisible by 3 and which is greater than equals to the square of 3. So which is divisible by 3 and greater than equal to the square of 3, which is equals to 9. So I go and cut the 9. Then I go and try to find the next number which is uncut, which is 5. So all the numbers which is divisible by 5 and is greater than equals to the square of 5. So anything number which is divisible by 5 and greater than 5 is not present, so I don't do anything. The next available number is 7. So again, all the numbers which is divisible by 7 and is greater than equals to the square of 7. Nothing, so I don't do anything. Then I don't find any numbers. Once I am done with it, all the numbers starting from the 2, all the numbers which are uncut. What are those numbers which are uncut? 2 is uncut, 3 is uncut, 5 is uncut, and 7 is uncut. All these uncut numbers, these will be the prime numbers. These will be the prime numbers. Let's take with the help of another example. Let's say that n is equals to 20. What we go and do? We can go and take an array and we go and put the number as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And then I have 14, 15, 16, 17, 18, 19, and then I have 20. I start with 2. All the number which is divisible by 2 and greater than square of 2. So I go and cut 4, I go and cut 6, I go and cut 8, 10, 12, 14, 16, 18, 20. Then I come to the 3, anything which is divisible by 3 and greater than equals to square of 3. So I go and cut 9, I go and cut 12 is already cut, 15 will be cut, 18 is already cut. I come to the 4 greater than 4 and greater than equals to 4 square. Divisible by 4 and greater than equals to 4 square. Not 4, it will be 5. No, next available number is 5. Actually, I did a mistake. After 3, the next available number is 5. So it has to be divisible by 5 and it should be greater than equals to 5 square. So I come and I don't find anything which is greater than 5 square, so I just leave it. Then I come 6 divisible by 6 and greater than equals to 6 square. I don't find any numbers which is same thing is true for the 7 divisible by 7 and greater than equals to 7 square. Nothing I go and find. Then next available is 11, so it should be available divisible by 11 and greater than equals to 11 square. I don't find any number that has to be cut. The next available is 13, same thing I do with the 13, divisible by 13 and greater than equals to 13 square. I don't find anything. Then I go and find 17, divisible by 7 and greater than equals to 17 square. I don't find anything, I don't do anything. Then I do the same thing for the 19th and greater than equals to 19 square. I don't find anything. In this list, I go and find what are the numbers starting from the 2 which is uncut. 2, 3, 5, 7, 11, 13, 17, 19. So these are all the examples of the prime numbers. These are all the examples of prime number. Now what I need to do is I have to go and convert that into the form of the code. So this sieve of eratosthenes, I have to go and convert this into the code. I want to go and convert that into the code. How do I do it? So in order to convert that into the code, what I do is, let's say to write a logical code. So now what I do is, let me go and define a array first. Let's say that I'm trying to do it for the n is equal to 10. So in the very beginning, I go and define a Boolean array where I go and put the values as true, true. Let me go and represent the true with the help of the title t, 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 t. And I go and put the 0, 1, 2, 3, 5, 6, 7, 8, 9, and 10. Okay, this is my array. This is the beginning. Now what I need to do is the same approach, right? I start from here. I start from here for the first. I start from here. And then typically what I do is, if this value is true, if this value is true, then for the powers of 2, so for this 4, I'll go and make it as false in this iteration. I'll come here, I'll make it false, then I'll go and make it at 6 and I'll go and make it as false. I'll go to this 8 and I'll make it false, and I'll go to the 10 and I'll make it false. Okay. The next iteration is the next available 2, which is this. I come from here and I go to the this, the next is 9 typically, right? So I'll start from here, I go directly to this 9 and this value I go and make it false, and then I stop it here. Then the next true that I look for is this one. So I start from here and then I see that 5 square is nothing, so I just go there and I cannot do anything, right? Next that I available that I go and see is this 7, and then again I cannot do anything, right? So once this whole loop activity is done, this array is left with the following. The array has been changed to this true, 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 false, true, false, true, false, false, false. And if I go and put the index, this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now we need to go and find that from the second index, from this point to this point, all those indexes where the value is equals to true, so I come here, this value is true, so I go and print 2. Then I come here, the value is true, so I go and print 3. I force, I don't do it. I come here 5, I go and print 5. I come here 6, I don't do anything. I come here 7, I go and print 7. I come here, I don't do anything. I come here, I don't do anything. I come here, I don't do anything. So I go and print 2, 3, 5, 7, which is a prime number. And this is the sieve of Arrhythmus algorithm, which is popularly known. The people who do the competitive programming, they sound to be very techy, right? When they use these terms like sieve of Arrhythmus algorithm, right? So I believe you guys are aware now. Let's quickly go and write the code for this, which will make things pretty simple for us. Array size will be the size, if n is equal to 10, then I have to take the array of the same size n. Now let's quickly go to my code and we'll try to write the code for it. So let me go to my VS Code. And the VS Code, let me go and define another function. Function print prime, and this is sieve of Arrhythmus algorithm. So I have to know. So basically, what this function does, this function tries to print all the prints. This function typically what will try to do? This function will print all the prime numbers less than equals to. Very first step that we need to do, we need to go and define a array. And in this array, let me go and put the values. So first of all, I will initialize it for I equals to 0, I is less than equals to n, I plus plus, and in this I want to set that prime, and then I want to set the value I is equals to, and I set the initial value as true itself. So this is I go and initialize the array. After initializing the array, I have to start from 2. So I go and write for p equals to second index, and then p into p is less than n, less than equals to n, and then I have to go and write I plus plus. This we have already seen that we only need to go and check till the square root of the size. And I go and write if prime p is equals to true, in that case what should I go and do? I should go and set that for, and I'll start with I equals to p into p. I value is less than equals to n, I plus plus, and I go and say that prime I equals to false. Now once it is done, typically I'll go and write another for loop for I equals to 2, I is less than equals to n, I plus plus, and I go and write that if prime I is true, in that case I can go and say that console.log I. This is the entire code that we have written for printing all the prime numbers. Let me go and copy paste this. And paste it here. Okay, so this is a question, right? Let's say that I go and call this function like this. Print prime SOE, and let's say this value is 10. As soon as I go ahead, first of all, what do I go and do this? When I go and execute these two lines of the code, it has created a prime array, which looks something like this: true, 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 true. And it is starting from 0, 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. I have to take one more. So I have to do it of the size 11. There will be one more t, which will be at the index 10. So this, till this, I have written the code. Fair enough. Now, in this for loop, the P starts from here. The P starts from here. And it is saying that I should only go and check till the square root of the n, right? So ideally, if it is 10, then square root of 10 will be equals to 3 point something. So I should only go and check, I only need to go and check till this point. Right? I don't need to go beyond that. Fair enough. So I first of all come with this p equals to 2. I am here, p equals to 2. Now at this point, this p is equals to 2 and this value is definitely 2. So I come inside this if block and this for loop, right? This for loop starts from I equals to p square. So this for loop starts from the I equals to 4. So I start from here, this point. And if this is the case, I have to go and set this value as false. So I go and set this value as the false. Then I go to the, this should be equals to I equals to, not I plus plus, it should be I equals to I plus P, it should be, okay. So I come here and then I should go to the C, I go and do this. And then I go to the 8 and then I go and do this. Fair enough. Once it is done, then I again run the second iteration. The p value now becomes equals to 3, right? So I'm still fine. So I'm here now, right? And since this is also equals to 2, so I go inside this. So p is equal to 9. So I directly start from 9 here. Since it is 2, I make it false. And after this, it goes. Once I move further, this becomes equals to 4. And the 4 square is, so this loop is also done. So once I am done with this for loop, the above array, which is the prime, looks something like this: true, 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 false, true, false, true, false, false. Right? So in this whole reason, now what I go and do, I have to go and start from I equals to 2 and I have to go till, I think this was also made false, right, in the beginning. This will be also false. When I go and run this, I have to go and print all the values of the prime I is equals to true. So I am starting from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. When I go and start from here, from the point number 2 and move here, what are the indexes where it is 2? So it will go and print 2. Then it will come here, it will print 3, 4 does not print, come 5, here it is 2, it prints 5, then it comes 6, does not do anything, goes to the 7, prints 7, and that's how the number will be the 2, 3, 5 and 7. So this is the logic which we go and write to get print of prime of ptosis. It should be I is equal to plus equals to P. This is what the code should be look like, right? So this is the code that we have written for the print of sieve of. Cool. So this is the code. I hope all of you are clear. What I'll do now is that I'll try to stop here because we have solved a lot of problems. There's a lot of concept that we have covered. My request to all you people who is watching this session, please make sure that after this session you are revising it. If needed, you have to watch it. What is for 3 times, 5 times. But make sure that the concept is inside you. Your concept of prime. What is a prime number? The concept which I use, that I should, when I'm trying to find the prime number, I should only go till the square root of n. Why is that? Right? This concept, this whole logic of finding the prime numbers less than n, this whole algorithm, I want you people to master that. Once you have understood it, try to write the code for it, and then, just for the accountability, tag me. What I'm planning to do is that once this session is completed, tomorrow morning, if you guys are already added to this community, you will get the notes. That's number 1. And then you will also get some kind of a practice problem, boss. And with the practice problem, I'll also provide you the solutions of that. So that not only we do it on the YouTube, you also get enough assignments so that you can do the proper pakka wala practice. Only thing that I expect is a little sincerity. If you are honest to your work, trust me, I'll make sure that you guys are doing everything, all the concepts, all the questions which is needed for the companies like a FANG also. Cool. So all this I'm doing is just for my passion of the teaching. I love teaching. I love connecting to you people. When you write comments, when you tag me, when you share the screen, trust me, I think that's the biggest kick and the motivation and the happiness for the entire day. So keep maintaining the love. Please share the channel with your friends. I need your support definitely, and I don't want to shy away from it. I need your people help, support, love. We are starting with JavaScript, DSA. Once it is done, then we go and talk about advanced JS. Then we talk about the back-end development. Then we talk about the front-end development. Then we talk about the TypeScript. Then we talked about the Next.js, right? Then we talk about, every advanced feature of JS. So this is around the JS stack. And for those friends of yours who are interested in the field of data science, I want to start a data science series as well on this channel from the scratch. So once I see enough motivation from the people, enough hustle and bustle, I would like to get started with the data science itself, where we get started with something called as a Python. Then from the Python, we go and talk about the DSA in the Python. Then we go and do the development in Python. Then we do the statistics in Python. Then we go and do the machine learning. Then we go and do the deep learning. Then we go and do the generative AI. Right? We'll try to complete the entire stack of data science. And for all those people who are in the first year of engineering, who are going to take the admissions, I'm planning to add few, the basic computer fundamental concept. For example, C programming language, DBMS, networking, operating system. All of this will be present on both my Hindi channel as well as the English channel. On Hindi channel, I have already started our Java batch. The name of the Hindi channel is Coding Shala. The name of the Hindi channel is Coding Shala. So tomorrow, alternate days, one day I'm coming live on our English channel teaching JavaScript with JS. Other day I'm coming live on our English channel, I'm teaching Java there. So that's all people. Thank you everyone. Thanks for joining me. I'll see you more. Keep supporting and keep learning. I want you guys to make the best out of it and try to be the top 1% techies. Thank you everyone. Good night. Take care. I'll see you more. Bye.